Hello, welcome to another episode of Physics is Easy with Mr. Jesse. For this tutorial, I'm going to solve a problem on spherical mirrors. This is one of the problems I've given in WebAssign on spherical mirrors. A man standing 1.54 meters in front of a shaving mirror produces an inverted image 20.4 centimeters in front of it. How close to the mirror should he stand if he wants to form an upright image of his chin that is twice the chin's actual size? So for the first sentence, we are given 1.54, and this one here is our DO. So this is the distance of the man from the mirror. So that is 1.54. And it produces an inverted image that is 20.4 centimeters in front of it. So this is our DI, that is 20.4 centimeters. So our DO is 1.5 meters. We could convert the meters into centimeters, so that would be 154 centimeters. Our DI here, by the way, is positive since it is a real image, and a real image is formed on the side where the object is. So this DI here is positive. The second sentence of this problem tells us that the magnification is a 2 because it says here an upright image of his chin that is twice the actual size. So for that sentence, we are given that the magnification is equal to a positive 2. The problem basically wants us to solve for the distance of the person from the mirror so that he will be able to have an image, an upright image that is twice his actual size. So we would call that DO2. That is what we are going to solve for. Now we begin by solving for the focal length because the focal length in this case is constant. It is the same mirror and the focal length does not really get affected whether the object is close or far away from the mirror. So we have our mirror equation, which is 1 over f, or the focal length, is equal to 1 over DO plus 1 over DI. Let's substitute the values. So that's 1 over f is equal to 1 over DO is 154 centimeters plus our DI, which is 20.4 centimeters, and that gives us the focal length to be 18.01 centimeters. Now let's set this focal length aside and focus on the magnification as given on the second sentence. So we have magnification is equal to 2, and remember magnification is just equal to negative DI over DO. So we have our magnification is equal to 2, that is just equal to negative DI over DO, which means that our DI is just equal to negative DO. So we have manipulated this equation and we're able to come up with this expression here, DI is equal to negative 2 DO. And this DO over here is actually our DO2, which is what we are going to solve for. So we will use the mirror equation, which is 1 over f is equal to 1 over DI plus 1 over DO2. Now we have our focal length, which is 18.01, so we will substitute that in this equation. So that's 1 over 18.01 plus 1 over our DI is negative 2 DO. Sorry, that should be 1 over 18 1 over 18.1 equals 1 over negative 2DO plus 1 over DO2. This is DO2. And now manipulating this equation mathematically would allow us to solve for DO2. So here DO2 would actually be equal to 9.005 centimeters, or approximately equal to 9.01 centimeters. And then we have solved our problem. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.